In this lesson, we're going to go over the solving of quadratic equations using the zero product property. The zero product property simply states that if I have two things being multiplied and they equal 0, then one of those two things could equal 0 and the equation be true. So let's look at an example. If I have x minus 8 times x plus 7 and that equals 0, that means x minus 8 could equal 0 and it'd still be true, or x plus 7 could equal 0 and be true, because remember, anything times 0 is 0. So as long as one of those two things is 0, then my equation is true. So in this case, we have to know all solutions, so we solve both equations for 0. If you notice, I get x equals 8 and x equals negative 7. So those are my two solutions that I would write down. In example 2, we're going to see another two things be multiplied and equal to 0. In this case, we have d and d minus 3. Those times each other should equal 0, so that means either one of those two things could equal 0. So d equals 0, that's already done. Go ahead and solve d minus 3 equals 0, and you get d equals 3. Therefore, my answer is d equals 0 or d equals 3, and I'm going to list both. You always have to list both. Either one would make this equation true. In example 3, I suggest you pause it after seeing it to get yourself a chance to try it on your own. It is very similar pretty much to example 2. Like right here, I would expect you to pause it if you want to try on your own. Notice again, s equals 0, that's already done for us, and then therefore my answer. Oh, and those three dots, if you're wondering, those three dots that look like a triangle before every single time, that's a mathematical symbol for therefore. So if you ever see me write that at the end when I solve a problem and I put those three dots in a triangle, remember that just means therefore. It's a shorthand in math. Let's go ahead and look at a slightly different problem. This is more like example number 1 again. So we have q minus 4, and we have q plus 9. I set both equal to 0, and I solved them individually. Again, these are one-step equations. If you don't remember how to do one-step equations, you might want to go review that, because you will need to know how to do solving equations for this portion to be able to be successful in this lesson. So my answer is q equals 4 and q equals negative 9. Let's go ahead and do a few more examples. I'm going to try to make them a little gradually more difficult. Let's see example number 5. So I have w times 5w minus 6. Again, I have two separate equations. W equals 0 and 5w minus 6 equals 0. Separate them. In this case, I don't have to solve for w on the first one because it's already done. The second one, I have a two-step equation this time because I have 5w minus 6. Remember, you add or subtract first, and then you divide or multiply next. So do your two-step equation. I have a fraction answer. I'm going to leave it as a fraction. As long as it's a simplified fraction, we are going to leave our answers as fractions in these problems. Our last two examples, we have r plus 1 times 2r minus 5. I set up two equations. They're both equal to 0 because either one could equal 0 for this to be true. R equals negative 1 or r equals 5 over 2. So remember, you have to have two answers for a quadratic equation. Usually. I can't say you have to. You'll eventually get to parts that you will not have two answers, like you might have two things that equal the exact same number. If it equals the exact same number, then you have only one answer. And then there will be times where it's not factorable, which we don't have in this case because they're all factored for you this time. You'll see this later on in lessons that there is a possibility of not having any answer. There is a no solution, one answer, two answers. In all of these examples and the ones for this lesson, we're going to focus on the ones that have two answers, because usually it will have two answers. And that's how you solve using two, like when you are factoring, that's how you solve when you are using the zero product property.